Hi, everybody. Carl invited me to speak, so if you like this talk, then pat him on the back, and if you hate it, it's his fault. All right. Well, technology of quality. Let's begin with a simple idea that was given to me as a young man growing up in Indiana, where we have winters and sometimes take a meter of snow overnight. My father would say, let's go get this snow shoveled. And I'd be like, well, why can't we wait till morning? And he said, well, if you do it when it's easy, you don't have to do it when it's hard. Turns out shoveling an inch of snow is really quick. You can do that in minutes. Shoveling 3 feet of snow, not so easy, could take all day. And it's much easier. So I've learned to apply this also to the idea of software development. There's a lot of things we could wait until it's a nightmare, or we could just do little things all the time. So I want to recommend this as a principle moving forward. The way I like to carry this out is through a series of 5 steps. You may recognize these. If these are unfamiliar to you, try them. You know, Carl said so. The first one, of course, is a clean start. So a clean start, take your local system, put it into a known valid state. Prove that it's valid, run the tests. Check out the recent code, do a git status, and there's no untracked files, there's no nonsense and noise. You're clean, and the test pass. You know that any problem you have is your fault, which is good, because I've spent a day because I pulled down somebody else's problems and thought they were mine, and I was debugging my code when I didn't have the problem. So clean starts first. Second one is easy recovery. Anybody here play video games, ever? Okay, when do you save your game? We have a thing called micro commits. When it's green and everything's okay, I can commit locally. That saves my game. That lets me move forward without fear. As we have heard from, by the way, thank you. When we are in an amygdala hijack, we don't think as clearly. When we're in that we have to make it or die, our creativity drops. We got to get this whole thing working. Well, what happens if you know 5 minutes ago all the tests passed and you could do a git revert and be right back? Well, now it's not scary. Now you become creative. Now you can learn. Now you can play. Right? It's nice when work is more like play. So, save our intermediate steps, get fast feedback. Well, what's fast feedback? Well, maybe run it really often, maybe run all the tests really often, maybe show it to somebody, maybe screenshot it, make a little screen recording, send it to somebody who matters to you. Feedback. And then they say, Tim, that's pretty good, but it would be much better if it would do this. And then I know exactly what to do next. So I don't have to think a lot, which is good if you're me. So easy integration is next. If I've had fast feedback, I've had frequent recovery, I've run the tests, I validate all the time, integration is a breeze. I can't tell you how many merge conflicts I've had in the past year in my code, but in my client's code, it seems to be about every time they try to push. Every time they push, they get a pull first, and they have huge merge conflicts. Probably not a good idea. That's waiting until it's hard. What is continuous integration? Every valid change on my machine hits all of the other developers' machines in the same day. And likewise in reverse. Okay, so that's easy integration, right? That's a good thing. And then that makes safe release, an automated release. We do it often. It's a non-event. We do it, a decent day for us is like 12 to 20 times a day. A bad day is fewer. So, okay, it sounds like a pretty easy plan. You've probably have you seen a 5-step plan like this before? Okay, well, you have now. So, what makes it hard to do, though? That seems pretty simple, 5 steps. Probably recite them back to me now if you wanted to try really hard, but I won't make you do that. Why is this so hard? Well, the thing that makes it hard isn't the plan. It's all the other stuff, right? And I like the story that we just heard a minute ago about the new developer who they had trouble getting themselves up to speed. They're trying to learn. Thank you. And suddenly when you pair them, they blossom. Well, why? Well, because they were an individual in unfamiliar territory. So, in the 80s, before you were born, we had a computer, a compiler, a text editor. Sometimes we didn't have a compiler. Sometimes we used a ROM basic. A bookshelf full of books, all the language standard books printed out, and three whole notebooks, and print magazines. You got new code ideas because they came in the mailbox in a glossy magazine. We did a lot of homework. You read everything you could about the language you were using and the architecture of the machine and how people do software. You studied, because there was no place to look for this otherwise, right? And the world was small, really small. Our software was small. If you had a software program that was 5,000 lines of code, you bragged about it. That's huge. We have like 5,000 files in the root directory. So the world was smaller then, and that helped us out. Well, things have changed. So, an introduction. Any one person, wow, I maybe should have hidden this and then asked the questions. What I find is one person knows somewhere between 5 and 30% of their application code base. The bigger the company, the less of your code base you know. Does that seem to be true? Okay. That's what I need, that feedback. So, of all the skills that are in daily use in the software department, any one developer might have 40% of them. Would you say that's true?
Yes, Tim.
Okay. Thank you. Any programmer probably knows about 30% or less of the different languages they use in a day. Do you know all of your Java? Do you know all of JavaScript? Do you know all of TypeScript? Every bit of it? Okay, your primary language. Let's just step off of this for a minute. Your primary programming language. What percentage of the syntax do you have memorized that you can just do without thinking? 20, 60, 70. Oh, that's a primary language. How many languages do you use a day, typically, when you're programming? If you include markup languages. I hear a typical number is about 4. 4 of them that we don't know very well. Okay, that's fine. So we don't know the code base. We don't have all the skills. We don't know the languages. We're peripherally aware of our deployment platform, unless you're working in ops. You maybe know a fraction of what your primary editor does. Who here uses Vim? Anybody use Vim? No. Okay. Thank you. I wrote a book on it. I have to bring that one up. Okay, is anybody using VS Code? Do you know all of the features of VS Code? All the keystrokes? What percentage do you think? 5, 10. Wow. May have met an end user once. Okay, that's one person. Know what we think is a good idea? We should take that person and give them an assignment to do all by themselves. I bet it'll turn out great. I'm that person too. Okay, how about all the things you need to know about the languages? How are you on accessibility, security, observability? Wow, I'm killing the tone in this room. That's brutal. Okay, how about CSS4? You got all your CSS4 and your HTML5 and your JS13 and Python 3.13 now. This slide is dated. JDK 25. You got all that? No? Okay, how about this? React 18.2, Django 4.2. Azure, AWS, GCP, Heroku. I always want to call it Heroku. I don't know why. I think it's heretic, something in my head. Engine Yard, okay, CI servers, your distributed version control, pipelines. Yeah, we know a bit of it. Yeah, you're right. That's kind of hard to be a person today. The world is bigger than us, right? Here's Java in 2 years. Here are all the releases. Who keeps up? It's hard. Here's JavaScript, the definitive guide. This was the 7th publication of the book. JavaScript was released last year when I gave this talk 4 times since the 7th publication of the book. 600 pages long, 83 modules in the library. Python has, I think, 280 files in its library because batteries are included. JavaScript frameworks keep changing. New ones emerge from time to time. How about, how do you like to make your web components? Oh, anybody using Haunted? Because this is the right month for it. Okay, there's a lot going on here. I barely know a few of them, and definitely the HTML element is one of my favorites. But I really need to be doing more React and maybe Svelte, and I don't know. There's a lot. There's a lot. In fact, there's more to learn than any human being can possibly manage, right? And that's before we get into testing, Frank. Can you tell I've had to expand my slide? I got this great list of all these most popular frameworks, and it's like, well, now they're not even important compared to these. The world changed out from underneath us too fast. But luckily, you don't have to know them all, right? That's how we survive. We just need to know the ones that our employer uses and the one our next employer will be using. And then we're probably fine. So, why is it in 2024 we're convinced that the natural state of things is that programmers should work alone on their own tickets? The truth will set you free, but first it will give you remorse. There's never been a basis for that should. It's a baseless should because someone would like it that way. Okay, so technology of quality, back to the theme. Can we augment individuals so that we don't have to have, well, the individual works, and then we have to have someone go over the work to find all the bugs in it, and then we have to have other people go run the tests on the work because there's bugs that we didn't spot. The bug spotter didn't spot that bug because it was also their bug. And you multiple editors, and then we go through the tests, and then the scans, and some more tests. And is there a way to augment people to where our process doesn't have to be so darn convoluted? Right? That's the question. How can we produce good stuff that goes through the system in one pass that's never rejected so that it can go out into the field as soon as possible? And that's what we're looking for. Hat tip again. The user experience world. Don't build things you don't need to build. Don't build stuff nobody wants. Then you have more time to build good stuff and spend time on it. Absolutely crucial. And by the way, one of the most encouraging movements, there's two super encouraging movements going on right now. And I would say that UX movement is one of them. So, I'm not going to spend a bunch of time there. We have other experts. Bridging user experience and technology is another whole world. This is key stuff. So if you take a look, user-centered product discovery, journey maps, personas, and all these things. If I only do those, I'm not going to solve a lot of problems because eventually we have to make some software, usually. Otherwise, why are we even bothering? So you come over here and we come up with these other things we do, and we take user stories, and we have a thing called role action context we like to do, and slicing. And we make user stories out of user stories and get them down smaller. By the way, a lot of people have no idea how to do this. They can only slice stories for assignment, not for delivery. That is a realm that needs a lot more of you involved. And the information is there. I can share a listicle with you with a whole bunch of resources. The world needs to learn to slice to deliver, not to assign. It makes a big difference. So example mapping and working out what the MVP is, that's all. There we go again. Then down to the bottom, how are we going to work? Well, we're going to swarm, mob, ensemble, whatever, source code and tests in development. This is where stuff gets made. And then we're going to come out to our pipeline. We're going to get feedback from users, and it comes back around. That's a whole big system that brings it all together. These aren't disconnected domains. We are all a company. Okay, let's stay what the code is. At that bottom part, that's key, because that's where the software is made. Semantic editing. I wrote a book on Vim. Do you know why I don't use Vim every day? Vim does textual editing, not semantic editing. Now, there are plugins, and I'm going to keep looking for better plugins, but it turns out if I open up JetBrains, and I say rename X, it doesn't go through and find every X and replace it with something. It knows that's this X, and it's being referenced from these places, and there's other X's are not this X. It's smart, it's semantic. You will find that JetBrains, some of the stuff with the language server protocol, even old Eclipse had a lot of semantic editing. If you're using text editing, it's like Jurassic Park or something. I mean, I'm watching, that's how we started. Don't go back to just text editing if you can have semantic editing, right? So we augment ourselves by having tools that understand the language, and that's powerful and useful. And now we have tools that are starting to understand the frameworks too. So more semantic editing is power for the individual. Coding with awareness of our failure modes. By the way, I worked with a client who, when I joined them, they had 20,000 bugs in their backlog. They were about 3 years from their first release. Do you know what those bugs were? What if I tell you that it was C++? Do you know now? They had no idea how to use pointers. They were using pointers instead of references when they should be using references. They weren't using the smart pointers. We threw away 80% of the bug list in a week or two by just going back and replacing pointers with references where they needed to be. Well, why? Because they didn't know that they had this defect. They weren't aware, they didn't understand it. They had warnings, but they just found ways to hack around the warnings. It's like trying to sneak a dirty joke past the censor, right? Instead of trying to figure out, what am I supposed to do correctly? Well, once they learned, of course, it went very quickly. So you need to know the failure modes. How can you know the things that could go wrong? Well, one of the best ways is scanners. We have lots and lots of scanners. You got Sonar Lint. Sonar Cube is great, but it's too late. I think I'm done when Sonar Cube gets it. Sonar Lint is part of my editing session. I'm coding with awareness. That's power. So I make a lot fewer mistakes, and when I do make a mistake, I learn from them a lot faster. You'll find many more tools like this for whatever languages you're playing with, PyPy, etc. And some of these tools have built-in features to help us learn continuously. Learning continuously means getting better. By the way, everything we do is just skills. You don't have to change your personality. You just add on some skills, right? We can do that. We do skills all the time. So look over here. Every single one of these menus, they list my hotkeys. Why don't I put one of those on a sticky and use it 20 times? And then I don't have to think about it anymore. It just becomes natural. How many of you ignore those every time and just keep using the mouse? Yeah, I know. Oh, how about this one? Show tips on startup? There's a box. Don't show tips on startup. I don't want to learn how to use this editor. I like to muddle through. I don't waste my time knowing what I'm doing. My ignorance is as good as their knowledge. Okay, learning at the moment of relevance. By the way, this is another thing. I have no relationship with Sonar Cube and Sonar Source, by the way. I am not a part of their world. There's no money that change. But I like what they're doing with the Sonar Lint. And one of the things they do is when they show a message, they give you a box, right? And it says, you can go take a look by clicking on it. It'll say, well, here's what's going on. Why is this an issue? And then underneath, it'll show examples of it done badly and examples of it done well. You can teach yourself to program by making mistakes in an editor that has access to a good linter. I actually learned C from the linter. True, this is back in the 80s, so it's been a while. Okay, but that doesn't tell me if the program works. It just tells me that it's well-formed and doesn't have certain security and style problems. How would I make sure? Well, you have to build your own linter. You have to build your own code checker. And you usually build that with unit tests. All of your unit tests and your component tests and integration tests, those are domain and application-specific linting tools that you run while you're editing so you can tell when you're making a mistake. So you don't build broken code for hours or days and then try to fix it at the end. Because if you wait till it's hard, it's hard. It's easier to do it while it's still easy. This is part of the technology. Micro-testing is what we call our little tests that we use in TDD and refactoring. I recommend these things, but when people hear them, they get that Marmite experience, don't they? When you've worked with tests, it's wonderful. But when you've been given code without tests and you're trying to inflict testing into it, that's pretty hard. And people can give up easily when they have a lot of things to do because somebody assigned them 23 tickets. And artificial intelligence. I don't know. I'm trying it. I think it's almost reached the level of palpable stupidity. I gave it I highlighted the code. It said, hey, generate unit tests for this code. And I thought, hey, that's cool. This was code written in a REPL, and I need unit tests. Go ahead, do it. And it wrote all the tests for a different function. And I was like, no, this one. And it went, sure, and did the same thing again, only worse. And it's like, dude, I pulled it out into a separate file, and I ran it again, and it did write tests. They didn't run. It's like, what's going on? Well, I find out that people do this, and they copy and paste it in, and then they fix the defects, and then they say it was much faster than had I written it myself. I think that they didn't use a stopwatch to make their assessment, right? Because people often don't think about the debugging time as the writing time. Well, again, instead of trying to replace people, the dream of AI is it will allow capitalists to hold on to their old money and not share it by paying salaries. I think that it could augment us, though, and let us write great code and build better systems all the time. And I think that that is a bright possible future, but that's not the second thing I was telling you that was really encouraging. So, is it ready? Well, not very, but we're going to give it a shot. Does it work? Kind of in some things. Is it helpful? Don't trust it. But check it out. The thing it should be able to do is, I've been playing with Fitten quite a bit, by the way, which is quick. So, so it should know things about your language and their libraries that you don't, which is nice. Now you say, hey, Fitten, how would you write a function that does this? And it pops it up there, and you see that it's including a function you've never seen before that's in your standard library. And you go, ooh, what is that? And you go to the help on that, and it's like, that actually is a useful function. Not here, but in general, now I know more than I knew yesterday, right? Every day, a little more. They did a study. Do people know the code better after GPT writes it? They debug it, they make it work, they say, hey, that was a lot faster. And then they say, okay, how well do you know that code? Could you fix something that's wrong with it? And they're like, no. I actually outsourced my thinking so that I could be seeming done faster, and I don't really know what I did, which is disturbing. We can do better, right? Generating unit tests, post facto, does it work? Sometimes, but actually I had a non-AI code generator generate mechanistic tests for some legacy code, and that worked really well. The tests were garbage, but they were absolutely correct. And if I made a mistake while refactoring, they definitely stopped me. So that was good. It was very mechanistic, and I did not save those tests. I built proper tests once I refactored. Is it good at explaining code? Strangely enough, it's good at that. I've had no problem. I give Fitten a passage, and I say, can you explain this to me? And it's like, yeah, what we're doing here, and it uses the context around the things and the namings, and it has figured out what I'm about. And I can look at somebody else's code and say, can you explain this to me? And it's like, yeah, pull up a chair. It's a 500-line function. It's going to be a while. But here's what it's doing, and it will be usually about right or close enough. So I think there's room here, right? That's also not the movement I'm excited about. Is it a great magic refactorer? Well, it seems to be worse than humans. And here's some, I got a chart that people had made. I borrowed this. I'll show you the reference for it later. So does it produce valid code? And some of these did produce valid code. Did it improve the code health once we measured it? Not so grand, like 68, 69%. That one actually didn't do so bad. Is it a valid refactoring? Does the test still pass? No. Not so much. Although, we're talking about the people who did your code as a crime scene and some PhD work being done here. Very clever folks. So they started using their tools, their scanners and metrics, to identify if the code is better or not, which, by the way, is possible, right? The fact that there are some elements of code quality and readable, can I try that again? There are some elements of code quality and readability that are subjective, but subjective is not untenable, right? If subjectivity was untenable, there would never be a restaurant, right? Everybody has different tastes in food. Well, then we could never build a restaurant. You can't have a restaurant. You'll never have a cook. Well, it turns out that most people like one kind of potato chip crisps better than another kind of crisps, but most people prefer crisps to, dried bile. So there is a band of subjectivity in there, but it's not that big of a band. It's not all-inclusive, right? So any audience has preferences. And you can write for an audience. Otherwise, we also couldn't write books or give talks. So when they gave it an ability to understand, this is Tornhilbarg, and I don't know if it's Monis or Mones, or I don't know the pronunciation. This is what happens when you read more than you listen. They came through it, and using CodeScene for fact-checking and adding fact-checking to their refactoring of their tools in the AI, now it knew something to shoot for. And it's getting numbers here like 98% with these different kinds of tests to be able to produce valid running refactorings. And I'll show you the picture of the article here in just a second. So, turns out, if a dumb AI can do this, what could you do? Right? What if you learned what the qualities are of good code? Couldn't you produce better code? We can do that. It's just skills. No big deal. Can it make you a better programmer, AI? Well, the jury's out. Some indications are that you get worse answers sooner. I don't know if that's progress. Will it augment or replace you? Who knows? And at what cost to the environment? And this bothers me a lot. We're spending an awful lot of energy, literally, to help you write code that you probably could have learned to write in about 25 minutes if you'd actually known more about your library and bothered to read the tips, right? You can't burn the planet down to write software. Okay, actual intelligence is my favorite. Combine the skills, knowledge, and experience of actual people and work in a cross-functional way. I like pairing, I like mob programming, ensemble, blah, 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 blah. I like swarming. I like all the different ways we can co-create code together that brings us together. So it's not one person with a thin, narrow stripe of knowledge, but it's all of us with all the things we know doing our best work. And you know what? When we do that, we often don't have to have 17 quality gates afterward that keep bouncing the code back at us and running up our work in progress, right? So I'm a big fan of actual intelligence. Someday I hope to acquire some. Well, speaking of that, what about business intelligence? So I got some pictures. This is I'm panning for gold here, okay? When you start looking at your code and your code base, and you can find some cool stuff out, and then sometimes it just comes up with a tray full of dirt. But here's some of the things that I've come up with that have been helpful. I'm taking a look just using Git, and Git says there's files added, deleted, renamed, or modified. So I said, okay, we'll take a look at the past like 20, I think, tags for this code base. Look what we're doing. Almost everything we do is modifying existing code. We know that, so the existing code should probably be amenable. We're adding new code, right here, and we're deleting old code, and every once in a while a rename or two. Okay, the question is this good or bad? That's not the question. The question is this appropriate for the stage we're at in the software that we're working on? Right? Is this where we should be right now? Am I recovering the quality for legacy code? Am I writing something new? Well, what if we take a look at this and it doesn't match who we think we are right now? well, then we probably need to think deeper. In fact, there are patterns here, things that we can recognize. Some people use conventional commits. Anybody? I do. Conventional commits? Why do I talk? Oh, no. It's a nice technique. It's basically you put a little prefix on the front of your commit message. And there's standard ones so that we can actually collect those and do some number crunching. So this is like the gray ones are chores. These bright green, very green ones are feature. The pale green ones are test. So there's things that people have self-reported that they're doing inside the code base. This particular one, almost everything they do is a chore. Well, that's reasonable. This is actually a system that's in maintenance, technically. So a lot of what they're doing is just keeping up with the libraries it uses. And then every once in a while, you'll see a feature, and then a whole bunch of docs. See that orange? And then some tests here and there. You see the pale green. Not very much of that. But this is correct. This is where they are. And it's true. And when we know that, we can start planning our work around that. How about merge sizes? We're getting close to the end here. But I want you to recognize this. What happens when you have big merges? Conflicts. Okay, I want you to recognize the scale in the number of lines. This is 35,000 lines. This is one merge. So is this one. This is a stacked bar chart of all the different merges. Holy crap, what's the color mean? Oh, well, it's over here. The number of files, 0 files to 500 files. That yellow one scared me. It changes everywhere. Okay, but I can see it here. Here's another one for a different organization. Look, there are hardly any files at all. Even when there's a lot of lines, they tend to be very contained, except for that one time they went and renamed a bunch of stuff, and see how that big yellow pile? Okay. And the really weird one, code lines. Okay, you go into Git, you find where you have a node inside your Git commit, and it has more than one child. That's where a split has happened. And then later you find where there's a node that has more than one parent. That's where a merge has happened. So you clip that out, and you throw it up there, and let this algorithm throw it on the screen in kind of some kind of a squiggle. It's all one continuous line with trunk-based development. It looks like you expect it to look. Now, it's a mess. It's a barbed wire tangle, but it's okay. This one's actually in maintenance. But look, something's been going on for a long time for something that's in maintenance. A couple of big squiggles. This one over here, they use branches. And look at all these. Short, medium-length squiggles everywhere. These are the guys that had the big merges. Their code looks like the way they operate on it. Now, thanks for setting up the patterns conversation. Here's the deal. There are patterns and shapes in our work. There's an idea from modernity. Remember? I know that was a long time ago. We're all postmodern and post-truth and everything. But from modernity, there was this idea that the world could be understood, that we could study it and learn its patterns and take measurements. And that underlying this, maybe it makes sense. There are things in the world that will make sense. And from that, we get, electricity and plumbing and construction and software, computer science. A lot of people reject the idea. They don't like the thought of it. They don't want it to make sense. But this does apply that there is sense to be made of the ways of working. And maybe how we do things actually matters. That's an unsettling thought for you. I'm sorry. But that's theory, Tim. You don't understand that's theory. I understand that that's theory. I'm okay with that. The pervasive challenge is convincing anyone that there is sense to be made here in software. We are told that there is only experience. There are no equations, rules, principles, or patterns. And people won't look. I'm challenging you to lose your faith in ununderstandability and maybe take a chance on patterns and knowledge. And where is this not a problem? That number 2 trend, data science. Those people know there's patterns in there, and they love it. And they're learning new things by examining the patterns and building the equations around them and visualizing the data. They know there's sense in the world, right? And they can show it because it's in the data. So again, that's Thornhill. This is the article I promised to show you. I won't pronounce it. It is actually the name of the study. If you want to take a shot of that. The AI, automated refactoring. So, where I want to leave you is maybe the world is a bit more understandable than we thought. Maybe the tools are really there, but we've been ignoring them and turning them off with the do not remind me. The question is, what do you actually need to build quality systems time after time, predictably, reliably, and build your career on that bedrock? This symbol is the curiosity over judgment symbol. If you want some of those, I have stickers. And I am Tim, and that's been my talk.